8-6 radian measures and the unit circle. A radian is literally an angle with its vertex at the center of a circle that intercepts an arc on the actual circle. Most of these have a radius of 1 radian. So if we look at the first set of examples, we're converting between degrees and radians. By going from degrees to radians, we're going to just multiply the degree by pi radians over 180 degrees. That will cancel out our degrees and be left with radians. Whenever you're writing radians, it's always something times pi. So a lot of times a fraction with pi in the numerator, or even a whole number times pi. And then if we're going from radians to degrees, you're going to multiply your radian by 180 over pi radians. And then those pi's would cancel out, so where you just have your degree left. So if we look at example 1a, we have 45 degrees. So we're going to take this 45 degrees and turn it into radians. So that's going to be 45 over 1 times pi over 180. Simplify if you can before you multiply. It's going to make your life a lot easier. So the 45 and the 180 are both divisible by 9. The 45 divided by 9 is 5, and then the 180 divided by 9 is 20. You can also divide both of these numbers by 5 to get you 1 and 4. So this is just 1 over 1 times pi over 4, which gives us pi over 4 radians. For B, we have 249.8 degrees, so we're going to multiply this 249.8 over 1 times pi over 180. If we wanted to, we could multiply straight across and then simplify. If we did that with this one, we would have 249.8 pi over 180, and then we would simplify from there. I can't have decimals in fractions, so I'm going to turn this 249.8 into 2,498, which means that 180 is going to turn into 1,800. So this is just going to turn into 2498 pi over 1,800. From here, these are both divisible by 2, so I'm going to get 1249 pi over 900. This can't be simplified any further, so we leave it. For C, we're given 80 degrees, so we're going to multiply this 80, or turn it into 80 over 1 and multiply it by pi over 180. From here, this 180 and this 80 can simplify. Those zeros can cancel out. And then 8 and 18 are both divisible by 2. So the 8 is going to turn into a 4. The 18 turns into a 9. So that's just 4 pi over 9 radians. And then with this one before, we should have written radians with this. So we're going to, oops. There we go. Write in the radians. And then we were done with that one. Okay. So for D, we have negative 36 degrees. So we're going to turn the negative 36 into negative 36 over 1. Multiply it by pi over 180. That negative 36 and that 180 are both divisible by 6. The 36 is going to become negative 6. And then that 180 becomes 30. And then we can both divide these by 6 again. So this is going to be negative 1, and this is going to be 5. So it's just negative 1 over 1 times pi over 5, which gives us a final answer of negative pi over 5 radians. If we look at example 2a, we are given 9 pi over 4. We're going to turn this into degrees by taking that 9 pi over 4 and multiplying it by 180 over pi. So these pi's are going to cancel. This 4 and this 180 are both divisible by 2. So the 4 would turn into 2. The 180 would turn into 90. Then we can also simplify those, and the 2 would become a 1. The 90 would become 45. So it's just 9 times 45 now. When we do this, we are going to make sure that we draw or write a degree symbol on this as well. So if we do 9 times 45, we get 405. So this is 405 degrees. For B, we're starting with 5 pi over 6. So we're going to multiply this 5 pi over 6 times 180 over pi. Once again, those pi's cancel out. So then we have the 6 and the 180 that are both divisible by 6. The 6 turns into a 1. The 180 turns into 30. So this is going to turn into 5 times 30, which gives us 150 degrees. For C, we're given 2 pi over 9. So we're going to take this 2 pi over 9. We multiply it by 180 over pi. Those pi's cancel out. Then 9 goes into 180 20 times. So we have 2 times 20, which is 40 degrees. For D, we have 4 pi. So this is, remember, is the same thing as 4 pi over 1. We multiply it by 180 over pi. We're going to cancel out those pi's. We're going to multiply 4 times 180, and we get 720 degrees. Moving into the unit circle, something that we need to fix in your notes is that star that's there underneath this table. It says 180 degrees is actually equal to 1 radian, and 360 degrees is equal to 2 pi radians. So 180 degrees is equal to pi radian, and then your 360 degrees is equal to 2 pi radians. This table just gives you a brief description and some help on basic degrees and what their radians are equal to. So 0 degrees is exactly 0 radians. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. Then moving over to the next part, you have 90 degrees is pi over 2. 180 is just pi. 270 is 3 pi over 2. And 360 is 2 pi. And then you have your unit circle to the right of that. First thing that we're going to look at with this unit circle is finding arc length. The length S of an arc intercepted on a circle of a radius r by a central angle of measure Thadian radians is given by the product of the radius and the radian measure of the angle. So S is equal to r times theta, and your theta must be in radians. So your radians times your radius is S, which is the length, your arc length. S is your arc length, okay? So for example 3, we're looking at a circle that has a radius of 18.2 centimeters. So for both of these examples, our radius, that R, is going to be 18.2. And we're asked to find the length of the arc intercepted by a central angle having each of the following measures. So for example A, we have that theta is 3 pi over 8 radians. So we are going to use that S is equal to R times theta. S is equal to R times theta to find that arc length. So in this case, our R is 18.2. We're going to plug that in, and we're going to have S is equal to 18.2 times 3 pi over 8. So again, if we wanted to multiply this straight across, we could. If we wanted to simplify before we multiply, we could do that as well. I'm going to multiply straight across. If I multiply straight across, that 18.2 times 3 gives me 54.6 over 8 with pi. You can leave the pi in the numerator, or you can put it out after the fraction. It's totally up to you. So once again, I'm going to turn this into a whole number over a whole number. So I have S is equal to 546 over 80 pi. These are both divisible by 2. So I'm going to go ahead and multiply both of them by 2 first, so that S is equal to 273 over 40 pi. This does not simplify any further, so this is our arc length. For B, we have a theta that is 144 degrees. So our first thing to do here is to turn this 144 degrees into radians. So we're going to multiply this by pi over 180. We are going to simplify this. The 144 and this 180 can be divided both by 6. The 6 goes into 14 twice. With 2 left over, 6 goes into 24 4 times. And the 180 divided by 6 is 30. So then from here, we can simplify even further because 6 goes into both of those as well. The 24 is going to be 4. The 30 is going to be 5. So this is 4 pi over 5 radians that we're working with. So now that our theta is in radians, we're going to use S is equal to R times theta. R, we said, was the 18.2 centimeters. So this is going to give us S is equal to R, which is 18.2 times 4 pi over 5. From here, we're going to multiply straight across. The 18.2 times 4 is 72.8. So this is going to be 72.8 pi over 5. Once again, I'm going to turn the 72.8 into a whole number, making the 5 a 50. So S is equal to 728 pi over 50. I can divide both of these by 2, so I'm going to get S is equal to 2 goes into 7 3 times with 1 left over, 2 goes into 12 6, 2 goes into 8 4 times. So 364 pi over 25. That our radius was 18.2. For our next example, we have that C is 5 pi over 3 radians. So because our theta is already in radians, we don't have to change anything with it. We can just use our formula. S is equal to our radius times theta. And we said before, so this is going to give us S is equal to 18.2 times 5 pi over 3. So if we simplify this, 18.2 times 5 gives us 91 pi over 3. 3 and 91 do not simplify, so it's just the 91 pi over 3. For D, we're given 210 degrees, so first we're going to turn this into radians. So 210 over 1 times pi over 180. This is the same thing as 21 pi, or 21 over 1 times pi over 18. So the 21 turns into a 7, the 18 turns into a 6. So it's 7 pi over 6. We're going to use S is equal to our radius times our radians. So R times theta. So S is equal to 7 pi over 6 times 18.2. Yes, 18.2. Okay, so from here, the 18.2 times 7 is going to give us 127.4 over 6 pi. So from here, we are going to move that decimal point over for both numbers, top and bottom, to give us 1274 pi over 60. From here, we are going to simplify. So the 1274 and the 60 are both divisible by 2. So this is going to give us S is equal to 637 pi over 30. The next part in our lesson deals with finding the area of a sector. We're going to be using the formula A is equal to our radius squared times pi over 2. You can use a calculator for this. You're going to be working with larger numbers most of the time. So when you're finding that number squared, if you can use a calculator, that's fine. For example 4, we're finding the area of the sector with a radius of 321 centimeters and theta of 15. So again, we're using A is equal to radius squared times theta over 2. So for this, again, your theta must be in radians. So we're going to change all of these thetas into radians. And so we're going to go from degrees to radians. For A, we have 15 degrees, so 15 over 1 times pi over 180. We can simplify the 15 turn into a 5, the 180 turns into 60. So this is also going to be 1 and 12. So this is just pi over 12. So this is going to give us A is equal to 321 squared times pi over 12 all over 2. We go ahead and multiply the 321 squared, and that gives us A is equal to 10,3041 pi over 12 times pi over 12 all over 2. So from here, we are going to divide the 103,041 and 12 to get A is equal to 8586.75 pi all over 2. So we're going to divide that number again by 2. And we are going to be left with the area is equal to 4,293.375 pi. And we are leaving these in terms of pi. For B, we're given a radius of 51 inches and theta is 45 degrees. So we're going to first turn the 45 degrees into a radian. So 45 over 1 times pi over 180. We can divide both of these by 9. This would be a 5. This would be 20. And then the 5 would become a 1. The 20 becomes a 4. So 1 pi over 4. So pi over 4 is our same radian for this. So again, we're using A is equal to our radius squared times theta over 2. So A is equal to 51 squared times pi over 4 all over 2. The 51 squared gives us 2,601. So A is equal to 2601 times pi over 4 all divided by 2. If we divide that 2601 by 4, we get A is equal to 650.25 pi over 2. So we're going to divide this number by 2 as well. And we're going to be left with our area is equal to 325.125 pi. For C, we have a radius of 454 feet and theta is 120 degrees. So we're going to turn the 120 into radians, multiply by pi over 180. And we're working with 12 and 18 if we get rid of those zeros. So we're going to have 2 and 3. So this is going to be 2 pi over 3. So this is going to give us our area is equal to our radius squared, which is 454 squared times 2 pi over 3, all divided by 2. The 454 squared gives us 206,116. So A is equal to 206,116 times 2 pi over 3, all divided by 2. So from here, this 206,116, we can multiply it by 2 and then divide it by 3, which is the same thing as multiplying it by 2/3. So the area is equal to 1374.10.67 pi over 2. Right now I'm just rounding, but in your calculator don't round. And then just from that 137,410.6667, divide that number by 2, and you'll get your most precise area of 68,705.3 repeating times pi. Again, we're leaving this in terms of pi, so your answer should have pi attached to it. For D, our radius is 134 meters, so our theta is 270 degrees. We're going to turn that 270 into radians by multiplying it by pi over 180. We're working with 27 and 18 here. 9 goes into both 3 and 2. So 3 pi over 2 is what we're working with for our radians. So again, your area is equal to your radius, which is 134 squared, times theta, 3 pi over 2, all divided by 2. So use your calculator. The 134 squared gives us 17,956 times 3 pi over 2, all divided by 2. So we're going to multiply this number by 3, then we're going to divide it by 2. We get 26,934 pi, all divided by 2. So then we're going to divide this number by 2, and we get that our area is equal to 13,467 pi. For our last part of our lesson, we are working with the unit circle to find exact values of each trigonometric function. We want to remember what we worked with in that lesson that we did our sine, cosine, tangent, and the reciprocals of these. So with your sine, remember your sine was representing y, your cosine was x, your tangent was y over x, your cosecant, which is the reciprocal of sine, is 1 over y. Your secant, which is the reciprocal of cosine, is 1 over x. And your cotangent, which is the reciprocal of tangent, is going to be x over y. The whole idea for you when you're working with this unit circle is that your ordered pair for that degree or that radian is what you'll be using to find the sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so we can, easiest thing to do with this, especially in your homework, test, quiz, anything, use your unit circle to help you. Okay, so for A, we're working with the cosine of 210 degrees. First thing you want to identify, cosine is what value? Well, cosine is the value of x. Cosine is x. So what we want to do is we want to find that 210 degrees on our unit circle and take the x value of the ordered pair for the 210 degrees. So on your unit circle, 210 degrees is what ordered pair? It's that negative square root 3 over 2, comma, negative 1/2. Now, if we're working with cosine, that's the x value. So the x value is going to be your answer. So it's just negative square root 3 over 2. For B, we're working with a tangent of 5 pi over 3. So tangent is what values? Tangent is y over x. So we're going to use both x and y from the ordered pair that goes with the 5 pi over 3. Which ordered pair from your unit circle represents the 5 pi over 3? That's the 1/2 comma negative square root 3 over 2. So 5 pi over 3 is the ordered pair 1/2 comma negative square root 3 over 2. So use that to find the tangent. Tangent is y divided by x, or y over x. So we're going to divide these two. So we're going to have tangent of 5 pi over 3 is equal to the negative square root 3 over 2 divided by 1/2. Remember your rule for division with fractions. Keep, change, flip. So we're going to have negative square root 3 over 2 times 2 over 1. Those 2's simplify to be 1's, so it's just the negative square root of 3 is equal to your tangent of 5 pi over 3. For C, we're working with the sine of 315 degrees. So if we're working with sine, that's our y value. Find the ordered pair for 315 degrees. 315 degrees is the same as the 11 pi over 6, which is the square root of 3 over 2, comma negative 1/2. So square root 3 over 2, comma negative 1 over 2. So that's our ordered pair that we're working with. If we're finding the y value from that ordered pair, it's just the negative 1/2. So the sine of 315 degrees is negative 1/2. For D, we're finding the tangent of 180 degrees. So tangent, again, is y over x. 180 degrees. Looking at this, we are working with 180, which is just negative 1 comma 0. So 180 is negative 1, 0. If we're doing y divided by x, we're going to have 0 divided by negative 1, which is the same thing as 0 over negative 1, which is just 0. So the tangent of y over x is equal to 0. Your unit circle, 4 pi over 3 is right here, which is the 240. So we're going to work with the negative 1/2 comma negative square root 3 over unit circle. 7 pi over 4 is here. So we're going to use the square root of 2 over 2 comma negative square root 2 over 2. Look back at your unit circle. Just to reiterate this, your unit circle has ordered pairs that go with each degree or radian. There is a pattern with these. Okay, so if we start at 0, starting at 0, going up and to the left, you have the same numbers that you're working with here. And they're either going to be 1/2 the square root of 3 over 2 or the square root of 2 over 2. Depending on the quadrant that they're in and where that quadrant is will depend on what your x or your y is either positive or negative. So with all of these, you're going to be working with the ordered pairs of the square root of 3 over 2 comma 1/2, the 1/2 comma square root of 3 over 2, and the square root of 2 over 2 comma square root of 2 over 2. It all depends on your quadrants, on which one's positive, which one's negative. So if you're working with your first quadrant, that top right-hand corner quadrant, both x and y terms in that ordered pair are going to be positive. If you're working with your second quadrant, the top left-hand corner, your x value is going to be negative. If you're working with your bottom left-hand corner, the third quadrant, your both terms are going to be negative. And then if you're working with the bottom right-hand corner, the fourth quadrant, only your y value will be negative. Okay, so anytime you have a 0, a 90, a 180, or a 270, you're working with either 0 or 1. And again, it depends on what axis you're on to depend where on that axis you're at, if your number is positive or negative in there. And then again, square root 3 over 2, comma 1/2, the square root 2 over 2, comma square root 2 over 2, or the 1/2 square root 3 over 2 will be what your ordered pairs are throughout this entire unit circle. Okay, and there is a pattern, so please make sure, if you can, try to remember this. In pre-calc, you're going to have to know this. You're not going to be given your unit circle in pre-calc, so you need to make sure that you have some kind of understanding with this and understand how this pattern works. For our next one, we have cosine of 4 pi over 3. So first off, cosine is x. 4 pi over 3, look back at 2. Negative 1/2, comma negative square root 3 over 2. If cosine is our x value, that negative 1/2 is our answer here. So cosine 4 pi over 3 is equal to negative 1/2. And then for f, we have sine of 7 pi over 4. So sine is y. So look back at square root 2 over 2, comma negative square root 2 over 2. If we're just taking the y value from this, that negative square root 2 over 2 is our answer. So the sine of 7 pi over 4 is equal to the negative square root 2 over 2. Now I want to take a